Chapter 2, Section 1, Solving Systems of Equations in Two Variables. This section is going to be 100% review. This is stuff that we talk about in Algebra 1 and Algebra 2. So this isn't going to be a terribly long or terribly intense video. This is just kind of a bit of a review, kind of get yourself back in the mind frame of thinking about solving equations and figuring out what it is we're looking for. So, system of equations, just as a review, is a set of two or more equations, okay, usually in x and y if we're talking in two variables. What we're looking for are solutions. Solutions are ordered pairs in the form x, y that satisfy both equations. And you can see there below it says this, the point of intersection. If it's going to satisfy both equations, if there's only one way that a single point can be on two lines, and that's where the lines cross. Okay, so if we think about what we're looking for visually, we have an xy plane, we have one line here, we have a second line here. This point right here where they cross, that is the solution. It satisfies both equations. That's the only point that is on both lines. So that is our answer. It's our solution. Okay, so it's where the two lines cross. So there are three methods to solving systems of equations in two variables. The first one goes extremely fast. It's not going to be focused on too intensely because it's not really the purpose of what I think when we talk about systems of equations. It's more, can you use a computer or a calculator? And that's really not what I'm after here. So method one is graphing. Steps, real simple, graph all the equations. And I'm saying use technology. With this being pre-calc, you guys are advanced enough. Type it into Desmos, use your graphing calculators, and then find the point of intersection. So I've got a couple of examples here. Solve the system by graphing. I've already graphed these for you. I've got a couple of screenshots here from Desmos. Just because, I'm not going to spend a lot of time doing this, and this shouldn't take you a lot of time. So 3x minus 2y equals negative 6, x plus y equals negative 2, so 3x minus 2y equals negative 6 is this red line, x plus y equals negative 2 is the blue line, and you can use Desmos. You can just click the point of intersection, and it will tell you what it is. So your solution here for number one is going to be negative 2 comma 0. Okay, and then you can do the same thing for the second one, y equals 4x minus 18 and y equals 3/4 x minus 5. Again, just type them into Desmos, highlight the point where they cross, it will pull up the answer, and your answer for this one is 4, negative 2. Now, one thing I will tell you, if you're going to be using the graphing calculator and not Desmos, when you graph these, you have to be in slope-intercept form like these two. If you're going to use the graphing calculator, if you're going to use Desmos, and you can see it here, will take standard form or it will take slope-intercept form. Either one is fine, but if you are going to use the graphing calculators, you're going to need to put it into y equals or slope-intercept form, so you're going to have to get y completely by itself. And that might take a couple of extra steps, but again, shouldn't take you too long. The focus of this lesson or this video is going to be the other two methods. The first one is the substitution method, and we talked about this in Algebra 2 when we're talking about three variable systems, and that's what this next video is going to be, is solving three variable systems. Again, just another section of review. So, substitution method, the three steps. Step number one, solve one of the equations for one of its variables. Step number two, substitute into the other equation and solve for the remaining variable. And step number three says solve for the second variable. So, I got a couple of examples here. So number one, solve by substitution. Y equals 3x minus 8 and 2x plus y equals 22. Now in this example, we don't actually need to do step number one because step number one is already done for us. This equation already has y by itself. Okay, so this is what it means when it says solve one of the equations for one of its variables. It means get one of the variables all by itself. It doesn't always have to be y. Sometimes x makes a lot more sense. Okay, so don't always think it's got to be the first equation for y or the second equation for y. In this case, this one wouldn't be terribly hard to solve for y, but just know that you don't always have to use y. If x is by itself or has a coefficient of 1, don't be afraid to move this y over here if it makes the most sense. Okay, so step number one is already done for us. We can move on to step number two then, where we're going to take what y is equal to and we're going to put it in to y for the other equation. So this becomes, let me move this up here a little bit, this becomes 2x plus what y was equal to from the first equation, 3x minus 8, and that's equal to 22. This is the only thing that gets replaced, and everything else in that second equation stays the same. If you just take this and put it right here for y, you're just going to get zeros across the board. It's not going to work. You're going to work yourself into a circle. So you've got to substitute it into the other equation. Whichever equation you solve for one of the variables, it goes into the other equation to make sure that we're able to solve this. Okay, so now we just got a basic Algebra 1 problem here. We can combine 2x and 3x to make 5x. We got 5x minus 8 equals 22. This is now a two-step equation. We add 8 to both sides. 5x is equal to 30. divide by 5, we can find that x is equal to 6. Now, there's step 2, substitute in the other equation and solve for the remaining variable. Step number 3 then says solve for the second variable. So we have a couple of different places. Now that we know that x is equal to 6, we can either put it right there or we can put it right there. I'm going to suggest we put it right there because then all we have to do is multiply and then subtract. And we'll have our y value. So we'll do the y value here in purple. Y is equal to 3 times, we know what x is now. It is 6. Whoops. 6 minus 8. 3 times 6 is 18. Minus 8. That's going to give us 10. So when we write our final answer, remember it's an ordered pair. X comes first with 6. Y comes second with 10. 6 comma 10 is our solution. Got another one here for you. 2x plus 3y equals 8. X minus y equals 2. So now this one, we're actually going to have to do step number 1 where we have to solve one of the equations for one of its variables. We'll do that here. We'll do that in orange. I think when I'm looking at this problem, I think solving the second equation for x makes the most sense because the coefficient there is positive 1, which means all we have to do is add y to the right-hand side, well, to both sides actually, to get x by itself. So we can say that x is equal to, we can either say 2 plus y or we can say y plus 2 since they're both going to become positive. And then there's step 1. Step number 2 then says take what you just solved for and substitute it into the other equation. That's going to be right there. So we're going to say 2, and there's x. So we know that x is now y plus 2. And everything else in that first equation stays exactly the same. Plus 3y equals 8. Now we're going to solve for y because we've gone from 2 variables down to 1, meaning 2 separate variables, x and y, into 1 variable with just y. So we'll distribute there to make 2y plus 4 plus 3y equals 8. Again, this is algebra 1. 2y plus 3y is 5y plus 4 is equal to 8. Subtract the 4. 5y is equal to 4, which means y is equal to 4 over 5. Now we get a fraction. Nothing that we can't figure out, nothing we can't handle. This is pre-calc after all. You should expect to be able to do maybe a little more challenging problems. So let's jump right in. So step number 3 then says solve for the other variable, substitute and solvent for the other variable. So we box this in red here. And we are going to take this and we're going to substitute it right there in for y. So we can say that x is equal to our y value, which is 4/5 plus 2, make that 2 over 1. Remember, when we're adding and subtracting fractions, we need a common denominator. Common denominator here is going to be 5, so we can say 4 over 5 plus, let's see, 2 over 1 becomes 10 over 5, because 10 divided by 5 is still 2. And now that we've got a common denominator, we just need to add our tops, 14, and the bottom stays the same, which is going to be 5. So then we can write our final answer. We have our x and our y, so we can say that our solution here is 14/5, comma 4/5, and that right there is our final answer. So there's method number 2, substitution. Method number 3 is the elimination method. This is the method that I like the most. I think it's the fastest. I think it's the easiest. When we get to 3 variable systems, I'm not going to show you the elimination method because the elimination method in 3 variables is a pain in the butt. It's a long process. It's a tedious process. Substitution, I think, works a lot easier. So we'll focus on substitution when we get to 3 variable systems in the next video. But when it comes to 2 variable systems, I really like elimination. We'll actually use elimination when we get almost done with the 3 variable system. So we will actually use substitution and elimination. But for right now, we're talking about elimination. So steps for elimination, number 1, multiply one or both equations to make one of the coefficients to be the same number. And then when I say the same number, it could be opposite signs, one positive, one negative, but the number itself has to be the same. And you get to decide which variable. Sometimes it makes more sense to do x, sometimes it makes more sense to do y. Sometimes it's just personal preference. It's truly your choice. Once we get the numbers to be the same, we can move on to step number 2. We're going to add or subtract the 2 equations together, and it's based on the coefficient from step 1. So if we decide for the y's to be the same number, the signs on the y's determine whether we add or subtract. It doesn't matter what the x is. Or likewise, if we went for the x's to be the same, then we don't look at the sign in the middle, we look at the sign on the x. If the signs are the same, we're going to subtract the 2 equations. If they're different, we're going to add, okay? Step number 3 then says solve for the remaining variable, and then once we get the first variable, then we're going to substitute it back into one of the original equations and solve for the second variable. So, got a couple of examples here for you. Solve by elimination. 5x plus 2y equals 34. 3x minus 4y equals 36. Now, you need to decide, do we want to make the x's to be the same or the y's to be the same? To me, this one says the y's should be the same because if I count, if I just look at the pairs, 5 and 3, 2 and 4, I feel like this is just a more natural pair to go together. So if I count by 2s and count by 4s, the first number that I think they have in common is 4. So that means I need to take this times 2. This one is already 4, so I'm just going to take this one times 1. If I'm taking it times 1, it's not going to change. It's going to be 3x minus 4y equals 36. Now, if you're going to multiply by something other than 1, you need to multiply the entire equation. It's not just the y. The whole thing gets multiplied by this too. So 5x times 2 is going to be 10x. 2y times 2 is positive 4y. And 34 times 2 is going to be 68. Now, we need to move on to step number 2. Add or subtract the two equations together, and it's based on the coefficient from step 1. So the coefficient that we decided to be together or to be the same was 4. The signs here are opposites. So different signs, we're going to add these two equations together. So I'm going to do step number 2 in blue. I'm going to add these two equations. I'm going to keep my signs organized. 10x plus 3x, I'm just adding straight down the list. 10x plus 3x is 13x. 4y plus negative 4y is 0y, and that's the whole point of the elimination method. It eliminates, it removes one of the variables. And then 68 plus 36. Let's see, 8 plus 6 is 14. Carry the 1, that's going to be 104. What happens when we're doing the elimination method is usually you'll get something that works out very, very nicely, because step number 3 then says solve for the remaining variable. What I've got here left is a single step equation, and usually this number in front of the variable goes into this number nicely or wholly, and this is another example where that does happen. So I'm going to divide here both sides by 13. 104 is divisible by 13. When you do that, 104 divided by 13 is 8. So we've got 1/2 of our answer. Now we need to go find the other half. So what color haven't I used yet? I haven't used purple. So step number 4 then substitute and solve for the second variable. Now you have some freedom here. Let me box in this x equals 8. You have some freedom here when you determine which equation you want to use. You can use any of these 4 equations. Now these two are kind of the same, or not kind of the same, they are the same. So you can kind of combine these into 2, but you can put it there, you can put it there, you can put it there. Either one, any one of these 3 equations, unique equations, is going to give you the correct answer. I always use the one that I feel has the smallest numbers, or maybe it might be the easiest to solve. I guess it really doesn't matter. I'm going to use this bottom left one here, and we'll do this in purple. So we'll say that 3, we know what x is now. We know x is 8 minus 4y is equal to 36. 3 times 8 would be 24. Minus 4y equals 36. We're going to subtract 24. So negative 4y. 36 minus 24 would be 12. And divide both sides by negative 4, and that will give me negative 3. So y equals negative 3, which means that we can then write our answer. We'll do it in lovely orange. It's going to give us 8 comma negative 3. And that is our answer using the elimination method. Now, had you chosen to do the x values to be the same, you would have eventually gotten the same numbers for your solutions. Your equations would have looked different. Your work might have been a little different. You would have found y first instead of x, but in the end, you would get 8, negative 3, all the same. One more example here, 4x plus 2y equals 14, 6x plus 3y equals 21. I'm going to keep my colors the same, so I know I did step 1 in red. So we need to decide if we want x's or y's to be the same. Again, it really doesn't matter. It's whatever you're most comfortable with. This time we'll make x's to be the same, just so we have an example of both. If I count by 4s and count by 6s, I believe the first number they have in common is 12. So I'm going to take this times 3 and this one times 2. So this is an example where you're going to multiply both equations by something. Doesn't have to be the same number, but we want one of the variables, one of the coefficients to be the same. So if we take the first equation by 3, 4 times 3 is 12x, 2y times 3 is 6y, and 14 times 3 is 42. And we're going to take the second equation by 2, 12x, that's with the whole point. This is also 6y, whoops, 6y, and 21 times 2 is also, 42. So if you get something like this, and if you were to continue the process, that's totally fine. Just make sure I have the right color. Went to blue next. So our x's are the same. Y's are also the same, but we're focusing on x's. These signs are also the same. So it said the same sign. If we have the same sign, we are going to subtract the two equations. So 12x minus 12x is 0. 6y minus 6y is also 0. So on the left-hand side, we're left with a big fat nothing. And 42 minus 42 is also 0. So we're out of variables. We got nothing left. If you ever run out of variables, if these and these also match, and you're left with nothing on both sides, if both sides match, then what your answer here is going to be is infinitely many solutions, okay? We don't want to use all real numbers in this situation because all real numbers implies that you can use any x and any y that you want, but that's not the case. There's a specific rhyme or specific pattern or relationship between x and y, but there are infinite number of combinations of x and y in that same pattern that will give you a solution. If you say all real numbers, you're not exactly correct because all real numbers says you can pick any x, pick any y, and you're going to get it right, and that's not exactly true. Okay, so we want to use infinitely many solutions. If we were to get a situation, let me do this off here in green. Let's just say we had something like 12x plus 6y equals 42, and 12x plus 6y equals, I don't know, 31. Let's just say it came out to that. And when we do our adding and subtracting, this case would be subtracting again. This would be 0 over here. 42 minus 31 is not 0. Okay, so if we run out of variables again, but we don't have something that's true. We don't have 0 equals 0. We have 0 equals something else. This time it's 11, could be -5, could be 12, could be 100, whatever. If you get something that doesn't match, then your answer is going to be no solution. Okay, there's no possible x and y that makes both of these equations true because the same pattern is not going to lead you to two separate results. So if you get something like this where you get 0 equals 11, then you get no solution. If you have 0 equals 0, then you have infinitely many solutions. And that's what the answer is to number 2. Visually, graphically, if we were going to graph this equation, what you would see is something like this. You would see a single line. What's happening here is both lines are exactly the same. It's one line graphed on top of the other. So if we were going to graph the top one in purple, and let's say we did the bottom one in blue, it would look exactly the same. Okay, both lines right on top of each other. For no solution, just a quick visual. If we did the top line in purple, it would look like this. If we did the bottom line in blue, it would look something like this. The lines would be parallel. There's no way the two lines cross. And really, remember, that's what we're finding is the place where the lines cross. And the only way the lines cross, or the only way the lines don't cross, is if they're parallel. So visually, that's what we're looking at. If we get no solution, we have parallel lines. If it's infinitely many solutions, then it's the same line. If we have a solution like 8, -3, then it looks like those two examples from the beginning where the lines definitely cross in one place, and there's our answer.